Hi everyone, I hope you're doing great on this 3-day weekend. I just wanted to create a review sheet for you, and I figured that the video from the other day might have been helpful. So I created the test, and I always tell you about what's on the test. So if you follow what we're doing here and you understand what we're doing here, then you'll do great. My suggestion would be to look at the notes that we've done, also go over the homeworks that we've done. I will put all the answer keys in there for you. And if you can follow along with this review, then you're going to be great. All right, so the first part is just vocabulary. Whoops. Okay, the first part's vocabulary. And if you know these words, then you're going to be good. Okay, and I made a multiple choice section with these definitions. So this is the vocabulary section. Hey, right here. This is the rock cycle diagram that we are familiar with. So the great thing about this video is if you want to just pause it and see if you can answer the questions yourself and then come back to it, you can do that. So you can use this as a great interactive way to study. So we can go through the answers here if you want to just jot down quick and then pause A, B, C, D, and E, see if you get them all right, and then I'll give you the answers. So A, hey, over here is metamorphic rock. Hey, C is magma. Hey, E is igneous. Hey, D is sediments. And B is sedimentary. So again, if you feel like I'm going a little too fast, you can, pause it, rewind it, or, go back. You can. But this is very similar to what you'll see on Tuesday. Okay, so the next diagram that we're going to look at is igneous intrusions. So that's right here. And if you want to pause it and write down what you think each one is, okay, it would be a good idea because this will be very similar, if not exactly, okay, what you'll see on Tuesday's test. You'll just have word banks for all of this. So the first letter, okay, is, hopefully everybody wrote dike. Okay, the second letter, B, okay, is laccolith. Okay, a laccolith is a larger igneous intrusion, not the largest. Okay, the largest is C, okay, which is a batholith. Okay, so remember an igneous intrusion is when the magma is intruding into pre-existing rock. So this tan rock here was already there, and then you have magma that's going to invade, right? It's going to invade in various forms, and depending upon what does form or is created, will have a certain name, right? So A is a dike, okay? B is a laccolith. C is a batholith, which I just colored over. Okay, C is a batholith. And we're up to D. D is a sill, and the way I always remember that is it goes horizontal, like a windowsill, as opposed to a dike, which is vertical. And then the last one here, which is E, and that's a volcano, and the way you'll see it on the test is a volcanic neck. Okay, so the inside of it is called the volcanic neck. So you have A, dike, B, laccolith, 2 C's for laccolith, okay, C, batholith, D, sill, and E, volcanic neck. Okay, so the next part is just looking at the charts that you have been working on for the past week, and I just jotted down a few questions that we can answer, and you can erase, or I'm going to erase this. Can I erase this? All right, it's not letting me erase it, but that's okay. So we'll leave it there. If we look at the questions underneath, these questions are just dealing with igneous rocks. So we're going to have to read through these big H's. Sorry, because I can't go back and erase it. The first question says, what is the texture of obsidian? So we're going to look at this chart, and I know you know how to use it. If you don't know how to use it, hopefully this will help. I'm going to highlight. So let me get my highlighter. Here's blue. I'm looking at obsidian. Okay, so this is obsidian, and this is my block. So I know that obsidian is an igneous rock. And that's the first thing. The question says texture. So I have to find out where the texture column is. So just as a review, you could fast forward this if you understand how to do it. This is for anybody who does not know how to do it, okay, or needs some reinforcement. This is the column for texture. So all of this is telling us texture. But I don't really want to know all of those boxes or rectangles. I really only am concerned about the one that corresponds with, hey, obsidian. So I'm going to do this. Okay, this is my pathway for obsidian. So when I look to see where it overlaps, the texture for obsidian is right here. Okay, glassy. So texture, obsidian, I follow it over. Hey, all I want to know, hey, is the texture for obsidian, and it is glassy. If you put non-vesicular glassy, that's fine. I would not take off for that. That is fine because it really can also be non-vesicular. And as you know, vesicles means like little pathways for the lava to flow, and it usually will result in pumice or scoria, okay, when you have trapped gases. But we know obsidian, and I've showed you samples of it, and I know Mr. Weavers must have it as well. Obsidian is black glass. But remember, if you slice it, it's not actually black, it looks clear, which brings us to understanding the difference between felsic and mafic. So again, I come down here. Here is my texture, hey, for obsidian. That would be the answer. If you put non-vesicular glassy, hey, you would get points. So the next question says granite, right? What's the texture for granite? So I'm going to do the same thing. I'm going to find my box that has granite in it, which is here. Okay, and then I want to only care about granite's texture, so I'm going to follow over, okay, to right here. Okay, so you would say that granite has a coarse-grained texture. That is my answer, so you could just write that down. Coarse. If I wanted to know the specific size, which was on one of the questions for homework, the specific size of the coarse-grained texture for granite, your answer would be 1 millimeter to 10 millimeters. Okay, and you found that right here. That's the size of the grain. Okay, that's the size of the grains. Okay, so for number 3, they're asking which rock can be both intrusive and extrusive. So remember, if we are looking at anything that is extrusive, that would be all of these rocks here, meaning that they formed on the surface of the earth. Extrusive. They are volcanic. If we're looking for rocks that formed on the inside of the earth, intrusive, that would be all of these rocks. Okay, so granite is intrusive, pegmatite is intrusive, diorite intrusive, gabbro intrusive, peridotite is intrusive, and dunite is intrusive. If we're looking to see what's extrusive, obsidian, basalt glass, pumice, scoria, vesicular rhyolite, vesicular andesite, vesicular basalt, rhyolite, andesite, basalt. So the only rock, okay, that is going to overlap, okay, is diabase. Diabase is in between. So you can see, okay, that diabase is both intrusive and extrusive. So that would be our answer. So we could write that down, that it would be diabase. Sorry, I know that this is not the neatest. The next question says, what minerals are found in scoria? So now I'm going to find my rock scoria, and I am going to look down at this part of the chart and see which minerals are found in scoria. So the mineral plagioclase feldspar is, okay, there's a little bit of biotite mica, pyroxene, there's a little bit of amphibole, and olivine. So let's do that again. Hey, you have scoria, plagioclase feldspar, biotite mica, a little bit of pyroxene, there's a little bit of amphibole, a little bit of olivine. So all of those would be your answer. Let's try another one just for more practice. What minerals would you find in rhyolite? So I'm over here now. Okay, rhyolite is where I am. Okay, so I have potassium feldspar. Okay, I have quartz. I have plagioclase feldspar. I have biotite mica, and I have amphibole. So if you were unclear of how to figure out the minerals for each rock, hopefully that clears it up. If you want, I will do one more example. If you're good with it, you can, proceed and go forward, but I will do one more example. Let's do andesite, right? So this was one of the questions that was on your homework which I did grade. So andesite is right here. I'm looking here. Okay, I want to know which minerals make up andesite. So there is a little bit of quartz, and a lot of you kept on resubmitting your homework, and I would say and quartz, right? There is a little bit of quartz. So let me just erase that so you can see. Okay, follow the line down. This is andesite. There is a little bit of quartz there. So quartz, plagioclase feldspar, biotite mica, amphibole, and there is a little bit of pyroxene as well. So that would be your answer. Quartz, plagioclase feldspar, biotite mica, amphibole, and pyroxene. So that's how you figure out the minerals. And then the last one says name 2 examples of felsic rocks. Okay, so we know that felsic is on this side of the chart and mafic is on that side of the chart. So anything from here over, hey, are considered felsic. Let me just clean this up a little bit. Okay, and we learned, okay, that the vocabulary word felsic means high in silica. And remember, we said silica is like sugar. Silica makes things thick, very viscous. We know, and if you don't remember, it tells it to you right here, that felsic is also light in color. So you don't have to memorize it. It's there for you. You just have to remember where to look for it. Okay, so if we're talking about felsic magma, again, here is the side of the chart that we are looking at. Felsic. Okay, that's felsic. If we want to know about the side of the chart that is mafic, right, mafic's on this side, and again, it tells you it is high in iron and magnesium. It tells you that felsic is rich in silicon and oxygen. So just one less thing you have to memorize, but you do have to remember where to look for it. Here is my mafic side of the chart. Okay, so mafic is darker in color. Again, don't have to memorize it, just have to remember where to look for it. So going back to my last question, name 2 examples of felsic rock. Hey, obsidian would be felsic. Pumice would be felsic. Vesicular rhyolite, granite, and pegmatite. These ones in the middle really are not felsic. Those would be more intermediate. Okay, so if you put any of those, that would not be correct. Okay, only the ones on the left-hand side. The next type of scheme that you guys learned, okay, are schemes for sedimentary rock. So I think this one's a little bit more straightforward. It's just a matter of reading it. And you can see that they are broken down into our 3 types of sedimentary rock. So I have clastic sedimentary rocks. I have my crystalline sedimentary rock, which are also known as chemical. And then down here, bioclastic, which are also known as organic. So let's see if we can answer the first question. Again, pause if you need to, see if you can answer these 3, and then see if you got them right. Number 1, which type of rock is made from the mineral halite? So I look for composition, right? Composition we know is what makes up. Those are the ingredients that make up the rock. So I immediately see the word halite, and I know that that's my composition. So I go over here and I say, all right, well, what type of rock is that? So my answer to number 1 is rock salt. Okay. Number 2, which sediment found in clastic rocks is the smallest? So this is just, using the chart. You don't have to memorize any of this. If you look, I am looking at clastic, okay, and it goes in size order, pebbles being the largest, clay being the smallest, and it tells you the size of the sediment. Okay, so number 2 is clay, okay, because that is the smallest. And then 3, which rock is clastic and has angular fragments? So I'm again up here. Hey, I'm looking at clastic and I'm just reading the comments. Okay, which one has angular fragments? There it is. Okay, breccia. Okay, is the answer. Is the answer. Okay, so that was a little bit more straightforward, I think, than igneous rocks. But if you just practice, hopefully it's easy and it's one less thing you have to memorize. And I always tell you, use the test to take the test. So you're going to get these charts. So if you see a question about any of these types of rocks, you can always look at the charts for help. All right, and then the last scheme is the metamorphic rock scheme, and it's broken down into foliated and non-foliated rocks. Okay, and then here's my rock names, and some of them should be familiar to you. So if you want to pause it, come back, see if you can get 1 through 4 correct, and I will tell you the answers. So number 1, what's the parent rock of marble? Remember that the parent rock is what the metamorphic rock came from. So if you forget, hey, just look at marble. Hey, look at marble. And it tells you where it came from. Okay, so it came from limestone and it came from dolestone. So you could write both of those answers down. Hey, you could write limestone. I'm just going to abbreviate. Hey, or you can write dolostone. Hey, either of those would be right. Remember, hey, the parent rock, hey, is what it comes from. So another example, hey, is, I think I gave you another example. Yes, number 4. Number 4 is a very similar question, just asked a little different. Which rock will likely form from the metamorphism of sandstone? So it's the same type of question as 1. Sandstone is a sedimentary rock, okay, that is going to make quartzite. Okay, I'm going to run out of room there. Quartzite. So if you forget, you just have to read through, hey, the comments, read through the descriptions. So here's quartzite. Hey, quartzite came from sandstone, right there. Hey, it tells it to you right there. So just familiarize yourself. Hey, familiarize yourself with the charts, and it'll make your life a lot easier when answering the questions. Okay, circling back to number 2. Provide an example of a non-foliated rock. Okay, so any of these rocks here would be good. And I'm just going to erase some of this so you can see it a little bit better. Okay, sometimes it lets me. So I have anthracite coal, hornfels, quartzite, marble, and metaconglomerate. Those are all non-foliated rock. Remember, non-foliated means it doesn't have the bands, like gneiss does. And then number 3, describe the texture and grain size of gneiss. And I just did that for you. So here is gneiss, and gneiss is foliated. So you would write that that is foliated for your answer. And when I ask you to describe, the type of grain size, you would then come back over here and say, oh, all right, well, it says grain size. I want to know the grain size for gneiss. So the answer is medium to coarse. So if you think I'm going too fast, you can pause it, go back. If you think I'm going just fine, then you can proceed. Hopefully this will help you out. Like I said, if you're able to do this for the test on Tuesday, you're going to get 100. Okay, so now true falses. These are the true falses that you saw on one of your homeworks. And so you'll see these again on Tuesday. And I did give the answers on your answer sheets for Schoology, but we'll do them one more. Number 1, each major group of rocks, follow only one pathway. Whoops. Let me straighten that out. What did I do here? Okay, so that is, as we know, false. That was the one question that I gave you. I asked you to correct it on your homework, and then you put many paths, right? Many possible paths. For our test, you don't have to correct it. You just have to tell me if it's true or false. 2, granite is an igneous rock made up of minerals, quartz, mica, feldspar, and hornblende. So let's check, right? So we have to go back to the chart. If I go off this page, it's going to stop my recording. So I'm going to ask you guys to check. Go to the igneous rock chart. Quartz, mica, feldspar, and hornblende. Are those the minerals that are found in granite? And the answer is yes, they are. 3, high pressure can change an igneous rock into a sedimentary rock. That would be false. It would be metamorphic. The most common extrusive rock is basalt, and that is true. We've learned that over and over. And that is where you're going to see the majority of the oceanic rock made from basalt. 5, the small particles of rock or the remains of living things that make up sedimentary rocks are called not cement but sediment. So that's false. Rocks made up of broken pieces of other rocks are called clastic rocks. That is true. A metamorphic rock that has grains arranged in bands is said to be non-foliated. That's false. We know that it's foliated. 8, the uplift, folding, and faulting help to expose rock to the surface, which is true. That's how it gets to the surface from being buried inside the earth. 9, a sedimentary rock can follow the pathway to becoming another sedimentary rock, and that is true. And then 10, a pluton is found on the surface of the earth. That is false. We know those are called volcanic rocks. Plutons are inside the earth. Here are some sample questions that you will see. These are the questions that you've seen on all of the homeworks. Again, I gave you all the right answers to your homeworks, but I picked out the ones that you should definitely know to try and, narrow it down so you're not studying hundreds and hundreds of questions. Instead, you have about 70 questions, 80 questions to pick from, and I will make your test from these questions that we've been going over. All right, so if you want to pause it on the document that I put in Schoology for you, answer these questions, and then come back and see if you got them all right. 11. Which of the following types of rock is produced by magma that cools deep below the Earth's crust? The answer is B, intrusive. Remember, there's clues: magma, inside, deep, inside. A, B, intrusive, igneous rock. You could definitely cross out D and C because we're talking about magma. Can't be sedimentary, can't be metamorphic. That's the thought process as you tackle these questions. 12. Which of the following is an igneous rock? Okay, so you can go back and look at your rock chart if you don't remember. And the only igneous rock is letter D, basalt. Limestone is sedimentary. Gypsum is sedimentary, and gneiss is metamorphic. 13. The size and arrangement of crystal grains in an igneous rock is called texture. Okay, and so we know that you have coarse grained texture, you have glassy, and you have fine. 14. The texture of an igneous rock is determined by the rate at which magma cools, right? We said the longer it takes to cool, the bigger the crystals, the longer it has to bake. Okay, if it cools quickly, the mineral grains do not have time to cool or form, so they're going to be really, really small, called fine, or microscopic, called glassy. 15. Which type of texture do most plutons have? All right, so you have to put it all together. Plutons form inside the Earth. That means that they take a longer time to cool. Coarse-grained texture. If you forget, you could always go back to your igneous rock chart and find intrusive, plutonic. Take a peek at the grain texture, and then it'll tell you that it is coarse. So again, there's lots of help that you can that can be had with the charts if you don't remember. 16. When all the grains in a rock are large and easy to see, the rock is described as coarse grained. So hopefully you're realizing that it's the same type of question over and over again to make sure that you understand, hey, how this all works and how it's formed. 17. The process by which sediment settles out of the water or wind and it's dropped, right? So it's being carried by the wind, it's being carried by the water, and then it is dropped. So we know it's deposition. And this is now talking about sedimentary rocks. 18. The process in which dissolved minerals, the glue, crystallize and glue particles of the sediment. Okay, so the gluing is cement, like rubber cement that you would use for, putting pictures together on a cardboard, if that's still done, which probably isn't. Okay, so cement. Okay, it is cementation. It is taking the minerals that act like a glue or an adhesive. 19. Most rocks that form from fragmental rock particles are classified as, and that's just the definition, clastic, right? Clastic sedimentary, as opposed to chemical. Chemical has to do with mineral composition. Clastic is just pieces of sediments, pieces of sedimentary rock. 20. Wavy bands of light and dark minerals visible in gneiss, probably formed from now we're on to metamorphic rocks. So it's D. And if you forget, look at your charts and you'll find gneiss only on the metamorphic rock chart. So you'll know heat and pressure was responsible for that. 21. Why is the conglomerate rock shown below? Over here. Good evidence that rocks form from other rocks. So it shows you that there's rhyolite. It shows you that there's sand grains. It shows you that there's gabbro, which is an igneous rock. And this was one of your questions that I explained in the last YouTube video. And the answer there is A, right? So conglomerate contains some non-sedimentary rock fragments. So we know that it could be some pieces of metamorphic rock. It could be some pieces of igneous rocks. 22. The diagram below represents fossils found in a bedrock formation located in central New York State. In which type of rock were the fossils most likely found? You should be thinking to yourself automatically, hey, it can't be igneous, must be sedimentary. So I'm between C and D. And look at the picture. They are from marine life. They are from oceans, right? They are seashells. So sedimentary rock, ocean, environment. And that's what should kind of like click in your head. If we're talking about fossils, fossils would be destroyed in a metamorphic or an igneous rock. So fossils only exist in sedimentary rock, and they are very, very rare. 23, which type of rock is represented by the map symbol below? So that's when you have to go back to your chart, right, and see which one we're talking about. And you're looking at the sedimentary rock chart, and you're looking to find, hey, this picture. That picture corresponds to limestone. I can't click back over to it, otherwise I'll lose the audio, but go back to the sedimentary rock chart, and that would be limestone. So match it up, hey, with the chart. And so my answer there would be D, a contact metamorphic rock that results from the alteration of limestone by contact with an igneous intrusion. So that's how that formed. All the other ones do not make any sense. You must see the word limestone to help you out with that question. There's a lot of fluff here, right? Contact metamorphic, hey, alteration. None of that really matters. All you're looking for is what does that symbol match up with to help you. And then 24, which sedimentary rocks are clastic and consist of particles that have diameters smaller than 0.0006. Again, this was on your homework. You have to go to the chart and find that diameter. Just be careful because it's telling you that it's smaller, okay, than 0.006. So we're talking about siltstone and shale, because when you look at that diameter, it's 0.006 or less. All the other ones are much, much larger. And then lastly, on this page, which physical characteristic best describes the rock phyllite? So phyllite is a metamorphic rock, so you have to go to the chart for metamorphic rocks and just look at the comments. Hey, what is phyllite like? Does it have a glassy texture with gas pockets? No, it doesn't, right? So when you look at the description, we're looking for foliated metamorphic rock, and it has particles of mica. So the answer for that one is down here. B, clastic texture, angular bioclastic texture. So it's D, foliated texture with microscopic mica crystals. So that one, again, you're just kind of matching up what it says on the chart. There's a lot of chart reading. Hopefully it makes it easier. 26, which sequence of change in rock type occurs as shale is subjected to the increasing heat and pressure? So you have to go back to your charts. You're looking at the metamorphic rock chart. Shale is a sedimentary rock, okay, and shale becomes slate, okay, and then after slate, it becomes phyllite. After phyllite, it becomes schist, and after schist, it becomes gneiss. So the answer to that question is B. So it goes shale to slate, slate to phyllite, phyllite to schist, schist to gneiss. You don't have to remember that. You just have to go back to the chart, and it is in that order, okay, coming down. So shale is sedimentary, and then you'll see on the metamorphic chart, it goes to slate, and then it goes to phyllite, and then it goes to schist, and then finally it goes to gneiss. So just take a peek back at that chart. Again, don't memorize it, just know where to look. And then 27, how do the metamorphic rocks, schist and quartzite differ? Go back to your chart for metamorphic rocks. Hey, so schist is going to be something that has foliation, and quartzite does not. After looking back at your chart and reading these choices, so it says that schist is foliated and quartzite is not. That is your answer. If you look at the first choice, quartzite contains the mineral quartz and schist does not. Well, they actually both do. So as you go through those choices, the only one that is true and makes sense is letter D. Schist is foliated and quartzite is not. 28, how do the metamorphic rocks, schist and quartzite differ? Oh, goodness gracious, did I write that twice? Yes, I did. So we can get rid of that. 29, the diagram below shows 4 rock samples. Hey, which sample best shows the physical properties normally associated with regional metamorphism? So really, you're just looking for the rock that is metamorphic. Okay, it doesn't really matter, hey, per se for the question if it's contact or regional, but A would be the answer for 29. You're going to use that same series of diagrams. Which rock shows foliated? A, right? A is metamorphic. It's also A. And if we were to look at these, hey, I could tell you that this is sedimentary, that's fossils. Hey, this right here is igneous. It's definitely going to be granite. And this one we would need more information. Might be basalt. Can't really tell. And then 31 over here, heat and pressure due to magma intrusions, hey, may result in what? What are we talking about? We're saying heat and pressure. All right, I'm automatically thinking of metamorphism, which is the best answer there, and that is B. All right, so if you are still with me and you came to the end, I basically just gave you all the questions that you're going to see on the test. Okay, they will be reordered, but this is your test. I want you to feel confident. You know the material. Mr. Weaver's said so many wonderful things about you. You have the notes. You have the practice questions, and now you have this review. If you know this review and you understand this review and you can answer all the questions, you will do great. Okay, we do have shortened periods on Tuesday, so I will be making this shorter. It won't be all of these questions, but I will pick out from these questions. Shoot me an email if you need any help understanding any of the things that we went over. Hey, if there was something that I went too fast on, you can always rewind and listen again. Just make sure you look at the charts. You'll get those charts. Have a pencil, and I will see you all on Tuesday. Enjoy your day off tomorrow.